Hello, so I'm Piotr, and I will talk about the types in DataFusion and types in SQL and types in Arrow. So let's dive in. Uh, some presentation slide with some kind of slide like why you should listen to that. So there are three basic reasons. One is the boring one. Well, I've been doing query engine for couple years now and been a Trino maintainer I am and did a lot of core stuff also around types and connectors and type mappings and all the edge cases around that. The other and more important is it will be about DataFusion and types in DataFusion. And the third one is that you are here, the door is closed, and you have no better option to do. So what is type system? Well, we use this term a lot, and actually the definition I think is pretty vague, at least even to me, even past those many years in the computer science. But we see type systems everywhere. And so the type system, well, this is a collection of types and the behavior and relations between them. And the type is something that defines what something is, what it can be, what are the logical values, what this represents, what are the allowed values. So for example, if I have a date, well, 27 September 2024 is today, 37 September, well, doesn't exist, right? Or if I have an unsigned int type, the -1 is not a valid value, right? So this is what the type system is for. It can also say like some type is wider or narrower or something. These are the relations between them. But type system alone is pretty useless until it's made a part of a bigger thing, of a system that really, well, a language, right? So you have values that are of a type, and then what you can do with them, you can put them to some action. You can invoke something on them, or you can invoke like some attribute of them. So these are the functions. And type systems allow you to say, hey, this function can be applied to this value or to a set of values or like to any value that has a certain type. It can also say like, oh, you see this function takes a 64-bit integer, but you have only 32-bit integer, and I can help you with that. I can convert that. So there are coercions. In some languages there are, in some languages there are not. But generally, this is the attribute of a type system and a language that uses the type system. And well, we obviously have statically typed languages like Rust, and we have dynamically typed languages like Python, for example, where you don't write types, but they are still there. Okay, so basically, this is the important slide probably because it has the biggest font. So type is really the data and the functions like that, what you do with the data, right? In the programming languages. Oh, this is a boring slide because small letters. Well, Arrow, everyone knows about Arrow because it's a DataFusion meetup, right? So the brief recap is a columnar memory format with blah, 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 saying why it's so cool. And in Arrow, you can represent arrays or vectors of data very easily, and you can process them very easily. So let's say I have just a list of some words. I mean words in English term, not words like 4-byte or 8-byte things, not the D word. So I have a collection of words. I can put them into a string array, or I can put them in a large string array, or I can put them in string view array, or two other options. So there are basically in Arrow, there are 5 different ways to represent a collection of or a vector of words. And Arrow also has a type system. There is like an enum data type. It represents a type of a vector. So when we look at the words and a collection, when we come from a language like Python or Rust or Java or whatever, we think, oh, I have a string and then I have a collection of strings. So a string is a thing, is a type, and a collection of strings is a type. I have at most 2 types that I'm interested in. In Arrow, there are 5 different types, and none of them is string. All of them are collection of strings. And those are the first-class citizens in the Arrow world. And well, there are also functions. There's a rich library of functions or kernels or however we call them. And what's interesting is for us living in the Rust world of static typing, Arrow is actually a dynamically typed language. when you think about like when you program Arrow, you have dynamic typing all the way. And well, SQL. I don't know where the SQL comes from for the presentation, but I think we will find out 2 slides later. But generally, SQL is a very interesting language, very like simple, whatever, query language. Some lie about simplicity, but the important part is that it operates on relations that has attributes, or in other words, it uses tables with columns. And those tables and columns or relations attributes, they have very precisely defined types. And well, they are known when you do a query, when you have your program, SQL program, you know those types. And in SQL, you also have functions, fortunately, because otherwise it would be useless. And those functions are defined in a very row-oriented manner. So they operate on individual values. Like first normal form says, like you don't dare put collections in SQL, in tables. So these functions operate on individual values most of the time, and SQL is statically typed. So you also do overload resolution. You can do. You know what you are calling when you type your query without running the query. You know which function you are actually invoking, and you can check documentation mode or something. Oh yeah, and DataFusion. So DataFusion, maybe we know already, is a SQL query engine built on Apache Arrow. DataFusion has, as we know already, columnar execution engine that's actually, sits on top of Arrow. And so when we process data in DataFusion, we use those arrays, the Arrow arrays. And not surprisingly, like the type system that we use in DataFusion, the Arrow type system, which is very nice integration between the two because there are no bridges that we need to cross. We just feel part of one happy family, which is awesome. Now let's see like with families sometimes. We love the type system because it exists, but it sometimes feels like not necessarily aligned with what we want to be, because DataFusion is a SQL query engine, not an Arrow query engine, right? And in SQL, we, for example, have a string data type or varchar, or however we call it. It's just one logical type. And in Arrow, we have a type that says string, but also how it's represented, those 5 different ways. So it's like, somehow the type system is overspecified. And sometimes it feels like, well, there are too many options in the type system, but also there are too few. For example, how do you represent cars in Arrow? Well, there is no type for that. How do you represent varchars with a specific length limit? I didn't see a type for that. How do you represent timestamp with a time zone, which is a different thing than timestamp with time zone in Arrow, which you find in many databases? Well, there is no type for that, and so on and so on. And how do you extend the type system, actually? Well, there is supposedly a way to do it in Arrow, but there's like a very, like not a second class citizen, it's like a 4th class citizen, I would say. And now let's move on, where it doesn't work great yet. When you look at the expression and the functions, they come from SQL. They are expressed, they are logically represent things that operate on single rows. Whereas we're gonna execute them on columns because we are a column execution engine. This is great at runtime. But from planning, from logical perspective, we express operations that are on particular values. And let's say I implement a function regex match that takes a string and a pattern and checks whether a string matches the pattern. And a string, the input string, may be 5 different ways expressed, like those 5 different arrays. The pattern can be 5 different ways. Oh, wait, but actually there are also, like in the typical query, the pattern will most often time will be a constant, actually, not a value that comes from a table. So DataFusion fortunately has a way to represent constants, which is with a dedicated thing called scalar value. And this solves an important problem because we don't want to have an array of patterns that are like a same pattern repeated every time. We want to realize actually this is the same value. So we want this to be represented concisely in the plan. But this thing also carries the type that it could be if it was a vector or array. So it's actually a string scalar value is actually 5 different things. A scalar value string that could be dictionary encoded if it was encoded. A scalar value that could be large string array if it happened to be stored as large string array, and so on. So we have actually 5 scalar values for a string and 5 columnar values for a string, which is like 10 combinations for each of parameters, with like 100 different call combinations for a single function. Like, how do I write optimal function execution code if it's so, if the input structure is so complicated? And yeah, so this is like complex. And well, so my point is that for functions, for those things that operate on logically on single rows, this is not so great, but maybe it's great for those relational operators like joins, unions, and so on, which operate like on big batches of data, right? Well, yes, maybe, but not exactly, because like, for example, what if I have table scan that scans 2 Parquet files and one has country that like whatever is like some collection of strings, and the other, like the Parquet writer was realized there's like only 5 different country codes or country names in the data and used the dictionary encoding. In Parquet, this is a Parquet writer a freedom to pick the encoding of the data. There is no constraint on that. So one Parquet file would produce very efficiently string arrays, and the other Parquet reader reading the first file would produce string arrays very efficiently, like 0 copy out of the file, awesome. And the other Parquet reader would produce dictionary encoded strings, and now they need to negotiate. There is like they need to agree on one representation, because we prescribe during planning process what the actual representation can be, because that's a part of our type system, which means we do unnecessary conversions of the data, which means we lose performance. So, well, SQL is statically typed, but doesn't talk about storage. DataFusion is a SQL query engine. Does it have to be like the query plans? Does the DataFusion itself as a programming language, should it be statically typed with prescribed physical representation, or should it not be? Maybe it should be dynamic. So what I would propose, or I do propose, is that actually we focus on the types that are logical, that are abstracted from the storage. And I call them, well, there's a proposal calling them logical types. I don't like the name. I want them to be the types in DataFusion. I want them to be the only types that we deal with. So the logical, like cross it out, there are D types, and they should represent everything, every type thing that we have in DataFusion. They should allow us to represent what we need without prescribing the storage. They should allow for extensions, which are like 4th class citizen today, maybe we can hack it somehow. The logical plans should use them. The physical plans, well, as on the previous slide, I think they should also use them, because otherwise we lose this performance optimization opportunity. The types need to know how they're represented. So they need to know their carrier type or the arrow representation type. And maybe there is one, maybe there is many, maybe like this relation needs to be very well defined. What's more, the dictionary thing and runtime and encoded thing, this is actually boring for a function implementer to handle. So if I have a unnest data or a join data or some other operator, a relational operator producing some RLE or RE or dictionary things in the plan, I want this data to be processable efficiently without every function having a special code path for dictionaries. So I want the engine, the part, the thing that invokes the functions, I want this to be implementing that logic, because then it can say, hey, I have expression on A, B, C columns, and all of these come from the same relational operator, and those, not by incident, they happen to have the same dictionaries, and I can do some optimization on top of that. Yeah, and what's more important, the functions themselves need to be way, way simpler than they are today. Like instead of like 100 lines of code for a single function that does concatenation, I want this logic to be like 2 lines, and everything should, boom, be the framework. So why not just do it today? There are some challenges. Well, there's a ton of work to do. And the path from where we are to the path where I think we should be is a very long road. So we need to find we need to get a map and find the path. And the important thing is how not to break everyone and everything else along the way. So that's a challenge. And there are some tickets that probably you can follow because there were discussions in the open, which I encourage you to follow. And I'm sorry, I'm 35 seconds over, but the shameless plug is that Andrew brought DataFusion stickers, which are at the end of the room, or not anymore. And there are also maybe some t-shirts left like that. So please take them so I don't have to take them home. Thank you.